everyone, I am Shubham Garg and welcome back to the lecture series of Tanner. So in today's video we are going to see how to create an 8:1 MUX using a 4:1 MUX. Okay, so you can see the circuit diagram on your screens that in this we are going to use a 4:1 MUX as well as a 2:1 MUX symbol to create an 8:1 MUX. Okay, so two 4:1 MUX are connected like this and this is a 2:1 MUX. So this is how an 8:1 MUX should be constructed. Now let's look at the truth table. So this one was the truth table for a 4:1 MUX. Now for 8:1 MUX we will be having three select lines, that is S0, S1 and S2, and finally we have the output Y. So here we have the combinations like 0 0 0 0. We will be having basically the 8 combinations. Alright, so here it is 0 0 1 1 0 0 1 1, and finally we will be having 0 1 0 1s. Okay, that is 0 1 0 1 0 1 and 0 1. And for the output we will be having the output from I0 to I8, that is from I0 to I1 to I2, and we are going to have up to I7, that is from I0 to I7. We are going to have these as an output. Okay, so for that we are going to use two 4:1 multiplexer and one 2:1 multiplexer. So good news is we have already created the symbol. So this is a 4:1 multiplexer. Now first of all I will just delete everything. Okay, so here we have a new cell, that is 8:1 MUX. Now here this is the 4:1 MUX symbol. I'm going to create instance. Now remember that the inputs of 4:1 MUX already have the sources connected. So if you are directly watching this 8:1 MUX video, I would suggest to watch the 4:1 MUX and 2:1 MUX video before, because you see when we double click the symbol there are already print voltages and the sources connected in the inputs. Alright, so these are our 4:1 MUXes, and here we have our 8:1 MUX. So in this we are going to add this 2:1 MUX symbol. Now 2:1 MUX symbol does not have these sources connected. You can see when we double click on it, it does not have any of the sources connected. Alright, so we have these MUXes. First of all we are going to supply the inputs. Let's just supply the inputs, that is I0, I1, I2, this will be I3. Okay, this one will be S0, this one will be S1, so this one will be I4 actually, and this one will be I5, and this one is I6, and this is I7. Alright, so here we have okay, S0 S1 we don't need to make it again because we are going to connect these S0 to S1s. Okay, and finally we have this select line. Yeah, this we have to make, that is this one is for S2. Alright, so we have our inputs. So we can see here we have our inputs. Now let's use the wire to make the connections. So this is for S0, and let's move S1 further a bit. Yeah, so now here we are going to use a wire again, and this one, as we can see, S0, we are going to connect it to S0, So this one is connected to S0 like this, and this one is connected to S1 like this. Alright, so now here we have the outputs. These outputs would be connected to this choose to 1 mux like this, and this output would be like this. Okay, now here we have the final output, that is Y. So this is our final output Y, and you see how clean our design looks because we have created the symbols. Let's just save it and let's add the ground and VDDs. Okay, so we are going to add ground. So there is this ground, there is this ground, and there is this ground. Alright, so now we are going to add VDD. So this is our VDD, this is another VDD, and that's another VDD. Alright, so we have our ground, we have our VDDs. Now let's add the sources. So as I am saying that these MUX already have the sources, so we are not going to add the sources from in I0 to I3 and I4 to I7. We are not going to add the sources, we are just going to add the sources in this S0 and S1 and S2. Alright, so here this is our source for S0. Okay, let me just extend this a bit. Yeah, so I'll just extend it like this, and I will make the connection here like this. Okay, so here I'm going to move it. Yeah, so now just copy and paste because we have this V bit, we need to have this for this S2. Alright, so just just create a ground again. Before that, let's add VDC, and then we will add the ground and voltages. So this is the instance. And let's add the ground. There is the instance for VDD. Alright, so this is the instance, and now one thing remains, that we need to add the voltage print. So here this is the voltage print. Okay, for voltage print we need to add voltage prints to S0, S1 and S2. I am not adding the voltage prints to I0 till I7 because these already have the voltage prints. So here this is the voltage print for S2, and this is the print voltage for Y. Again I am showing by double clicking that this already, the 4:1 MUX already has this. Alright, so now we'll move again towards our design. So here is the schematic. Now let's save it. So this is how our final schematic looks like. Now let's try to simulate and run the schematic. First of all, we are going to set up the simulation, and we need to change the pattern as well. Okay, we have already did this because we ran the 4:1 MUX here. So here we are going to change the patterns. You see, now we have these kind of 8-bit patterns. Alright, so here I am going to add, this will be 4 times 0, 4 times 1, or let's say not 4 times, let's add a 2 times pattern. Okay, that is, this is for 0101. Okay, we forgot the enter. Yeah, Now this one, this one will be 0 1 0 1 0 1 0 1, this pattern, and let's add this pattern as 1 1 1 1. Let's see. Okay, I'm just adding the 8-bit patterns. Let's make this as 8-bit as well. Okay, these are the patterns I have added according to the truth tables. So now let's just run the program, and since I have just added randomly, that is S0, S1, S2 could be random, it won't be according to this. So basically we will be getting on some combination some input at the output. Alright, so let's just start the simulation and let's see if our design is working correctly or not. Okay, and let me tell you, we are going to get a very messed up plot because there will be a lot of plots in this. You can see the traces, that how many traces are there. Oh my god. And okay, so it is difficult to analyze, but this is how we are getting the plots. All right, so yeah, we can see here that these are our I0, I1. You can see, let's see the output, what it is mimicking. Okay, let me just remove these plots. Let's delete. We will see if one of the plot is getting there or not. So I am just going to remove some plots. Yeah. So I think this is fine. This is a bit fine. Yeah. So now we have, let's see, this kind of waveform, that is when both of these are 0 zeros. We can see it is mimicking I1. Okay, no, it is when the combination is 1 1 1. Yeah, when the combination is 1 1 1, it is mimicking I1. So I1 is at the output. Similarly for this combination, till this combination, it seems like some plot is at the output. Basically this is how the thing works, and we need all the plots to analyze this thing, but it seems that our circuit is working fine. So this is how the thing works. So we have successfully created the 8:1 MUX, and now next thing is to create the symbol of this 8:1 MUX. So again, for the symbol, what I am going to do is I am going to leave these inputs because these already have these print voltages. I am going to remove these select lines, the inputs at the select lines, and just imagine if we added the inputs everywhere, how difficult would it have been. Okay, so this is the symbol. This is our final schematic, and I am going to generate a symbol. So I am going to click on cell, generate symbols. And here I'm going to click replace. So here we have our 8:1 MUX. okay, which we are going to use later on. So this is our 8:1 mux, and I'm not going to run that 8:1 mux again, because in the next video I'm going to directly use this 8:1 mux symbol to create a new 16:1 mux, finally a 16:1 mux, and we are going to run that 16:1 mux. Okay, so this is all for this video. See you guys in the next video.